Hello students, welcome back to my channel Physics in a Nutshell. In my previous video, I had explained the important definitions of electricity. So in this video, let us study about Ohm's law. So I hope you all understood the basic definitions of electric current, potential difference and electrical resistance along with the SI units and formulas we had discussed in my previous video. So if you haven't watched my video, I will be sharing the link in the description below. So please watch the video so that all the definitions will be clear for you. Now let us move on to the important law of the chapter, that is the Ohm's law. So as we all know, the German physicist Georg Simon Ohm, he found the relationship between the current and the potential difference. So, according to the Ohm's law, the current is directly proportional to the potential difference. So, this means as the value of the current increases, the potential difference also increases. So, current is directly proportional to the potential difference. But under the condition, physical conditions like temperature remains constant. Physical conditions like temperature remains constant. Basically, this is the condition for the Ohm's law. And this particular relationship between the current and potential difference was given by Georg Simon Ohm. So this particular law is named after the physicist and it is named as Ohm's law. According to the Ohm's law, the current is directly proportional to the potential difference under particular condition. The condition says that the physical conditions like temperature remains constant. So this is very important to remember. So according to Ohm's law, the current is directly proportional to the potential difference when the physical conditions like temperature remains constant. Now let us demonstrate the Ohm's law with the help of a simple experiment. You can also perform the experiment in your laboratory by using the electrical equipments. It is very easy. So I will just explain through the circuit diagram. As we can observe here, we have taken a battery and connected to the resistance. We have taken a resistance wire, that is XY, and an ammeter and a plug key along with the voltmeter. So these are the materials required to connect the Ohm's law circuit. This is basically called as a Ohm's law circuit, and the materials required are battery, the connecting wires. We have taken a resistor, that is XY. Basically a resistor is the material which can obstruct the flow of current. And ammeter, we have taken a plug key. Plug key is nothing but a switch. The same function, the plug key and the switch, both of them have the same function, on and off. So we have also taken a voltmeter. So this is how we have connected the Ohm's law circuit. Now let us discuss about the Ohm's law circuit connections. Starting from the battery, the positive terminal of the battery is connected to one end of the resistor. I hope it is clear. Then the other end of the resistor is connected to the positive terminal of the ammeter, and the negative of the ammeter is taken to the plug key or the switch. And one end of the switch is connected back to the negative terminal of the battery. You can see here very clearly, this is the negative terminal. So this is a complete series connection. I repeat, the positive terminal of the battery connected to one end of the resistor, another end of the resistor is taken to positive of the ammeter and negative of the ammeter is taken to the plug key, and another end of the plug key is taken back to the negative terminal of the battery. So that is how the series connection is completed. Then you would be wondering, what is this voltmeter? It is separately connected. So voltmeter is always connected parallel to in the circuit. So the voltmeter is given a parallel connection to the resistor. You can see very clearly to the XY, a parallel connection is taken and it is connected to the positive and negative of the voltmeter. So please remember, ammeter is always connected in series in the electrical circuits and voltmeter is always connected in parallel. So here we can very clearly see in the circuit that ammeter is taken in a series connection and voltmeter is taken in a parallel connection. So this is how the Ohm's law circuit can be connected, and let us understand how it works. So basically, we are going to switch on the circuit. As the current flows, we can see the direction of the current over here from the positive to the negative. The arrow marks indicate the direction of the flow of the current in the circuit. So as the current is flowing in the circuit, the ammeter and voltmeter will show some deflection. So we need to mark the reading. The ammeter is showing the amount of current flowing in the circuit and the voltmeter measures the potential difference across the ends of the resistor. So that is how we need to measure the amount of current and potential difference. Now let us prepare a simple tabular column with the current and voltmeter readings, and then let us this is how we are going to make a simple tabular column, and let us perform the same experiment in 4 to 5 steps by measuring the current and potential difference. And as we are changing the voltage, we keep on changing the voltage and then we measure the values of the current and potential difference. Take the values and then divide. Here in the third column I have written V by I. That means we are dividing the potential difference by current, and then we need to note down the readings over here. So this is how we have to fill up this tabular column by repeating the experiment 4 times. So we are going to get 4 set of readings. As we take up the readings of the ammeter and voltmeter step by step by increasing the number of cells. Initially when we take one cell and record the readings of the ammeter and voltmeter, and we are going to note down in the tabular column. Then in the next step we are going to take 2 cells, increase number of cells and measure the ammeter and voltmeter readings. So this is how we are going to repeat the experiment several times by increasing the number of cells. So for example, let me show you in the tabular column by taking the ammeter and voltmeter readings in this manner. So here we are going to step by step increase the number of cells. So 3 times I have repeated the experiment and note down the readings. So here in the first step you can see the ammeter reads 0.12 ampere and the voltmeter reading is 0.3 volts. Now we are going to repeat the same experiment by taking 2 cells. As I told you, we are going to increase the number of cells in every step. So in the second step, what happens? The ammeter reading is 0.2 ampere and voltmeter reading is 0.5 volt. Similarly, in the third step, when we are going to take 3 cells in the circuit, we are going to increase the number of cells and once again measure the ammeter and voltmeter reading. So here we are getting the ammeter reading as 0.3 ampere and voltmeter reading is 0.75 volt. So this is how we are going to record the ammeter and voltmeter readings respectively. Then later on we have to divide V by I. So for the first step, the V by I value, when you divide 0.3 divided by 0.12, the answer is 2.5. Similarly, here also we are going to divide both V and I. So that is how you are going to get 2.5 in each case. So from this tabular column, it is very clear that the V by I value is a constant, and this V by I is nothing but the resistance, electrical resistance. So from this Ohm's law experiment, it is very clear that the current is directly proportional to the potential difference. You can see the values over here. As the current increases, the potential difference also increases, whereas the resistance remains the same. So I hope the concept is absolutely clear. According to the Ohm's law, as the current is directly proportional to the potential difference. The meaning is very clear. when the current increases, the potential difference also increases, but the resistance remains the same. You can see here very clearly, and experimentally we have proved the Ohm's law. Now, taking the set of the values of V and I, we can plot a graph. So let us see how to plot the VI graph. Basically, the potential difference is taken on the y-axis this way. The potential difference is taken on the y-axis and current is taken on the x-axis. So this is the VI graph. And when you take the set of the readings which we have measured in the Ohm's law experiment, we have taken the voltmeter and ammeter readings step by step. So those particular readings we have to plot over here. All the set of points we are going to plot here by taking the potential difference on the y-axis and current on the x-axis. So when we are going to plot, the graph is a straight line graph. So from this experiment, it is very clear that the substance which obeys Ohm's law, that is called as ohmic conductor. And for all the ohmic conductors, the VI graph is a straight line. So basically here we have two types, ohmic conductors and non-ohmic conductors. The substances which obey the Ohm's law, they are called as ohmic conductors. And for all the ohmic conductors, the VI graph is a straight line graph. Whereas the substances which do not obey the Ohm's law, they are called as non-ohmic conductors. So I hope the Ohm's law is very clear, and even the circuit and graph of the Ohm's law is clearly described in this video. So please follow my videos for the further concepts, and do like, share and subscribe to my channel, and I'll catch you in the upcoming videos. Thank you.